What is database normalization? See, database normalization is a systematic approach to organize and structure data in a relational database. And why do we need to organize and structure the data in a relational database? To minimize the redundancy. This is one of the most important aspects of database normalization, that we need to minimize the redundancy, then to reduce the risk of data anomalies and inconsistencies, because we cannot have wrong data. Anomalies means mistaken or wrong data, and inconsistencies. That means like where we are storing name, in that column we only need name, right? We cannot add age or phone number in that column. So there should be consistency in the data to enhance data integrity. And when we have an organized and structured data, it makes it easier to manage the data and query the database. Then there are multiple different levels of database normalization, and those levels are known as normal forms. So the first level is first normal form, second level is second normal form, then we have third normal form and Boycott normal form. With every level, with every normal form, our normalization, or we can say our database structure, keeps on getting better, right? And today in this video, we are going to discuss the first normal form, all right? So hello learners and welcome to Constant Learners. If you haven't already subscribed to my channel, please do so, and don't forget to hit the notification bell as well, so that you can get notified every time I upload a new video. Also, if you like this video, don't forget to give it a thumbs up and share it with your friends. Now let's get started with the first normal form. Now there are 4 rules to transform a table into first normal form. Now we can see this table here wherein student ID is the primary key, then we have the name column, and then we have the project column. Now the students have worked on either one single project or maximum 2 projects, like Ram and Neelam. These 2 students have worked on 2 projects, P1, P2 and P4, P5. And we can see that both the projects are being mentioned in the same single cell separated by a comma, right? Here also we have P4, comma, P5. That means both the project names are mentioned in the same cell in the single column separated by a comma. Such columns or such attributes are known as multi-valued attributes. And if there are multi-valued attributes in a relation means a table. If we have multi-valued attributes in a relation, then we say that the relation or the table is not in first normal form. So right now, our table is not in first normal form. To transform the table into first normal form, we need to have atomic values in each column or each attribute. That means we need single valued attributes, right? So attributes must have atomic values, or we need single valued attributes. Only then we can say that our relation is in first normal form. Now there are multiple ways to transform this relation into first normal form. Let's see all of those ways one by one. The first format could be like this, wherein we are using separate rows for separate projects. Like Ram was working on 2 projects, P1 and P2. So now we have 2 rows for the student Ram. His student ID is 1, name Ram. He's working on project P1. His student ID is 1, again Ram, working on project P2. Then again here we have 2 Meenu. Meenu is working only on single project P3. And Neelam is also working on 2 different projects, P4 and P5. So we have 2 different rows for Ram and 2 different rows for Neelam, because they're working on 2 different projects. But in this case, there's a lot of redundant data. Like we are having 2 different rows for the same student Ram. Then we have again 2 different rows for the same student Neelam. So normalization, we are using normalization to reduce the redundancy of data. But in this case, in this format, we are getting a lot of redundant data. Now here we have only 3 students. But what if there are 1,000 students? And out of 1,000 students, 700 are working on 2 different projects. Then in that case, 700 students will have 2 different rows, wherein their basic data, that is student ID and name, will be repeating 2 times, right? So we will get 1400 rows, right, for repetitive students, which is not very feasible, which is not a good database design. Also, in this case, student ID cannot be the primary key because the student ID is also repeating 2 times. So we can have project as the primary key here because the projects are all unique. But then again, this design is not very feasible, not very consistent with the requirement. That is, we do not want a lot of redundancy in our relation. So then let's discuss the next format in which we can store this data. Now again, we have student ID and name, but now we are separating the projects into 2 different columns as project 1 and project 2. So Ram is working on P1 and P2. His first project is P1, second project is P2. Meenu is working only on one project, so here we have P3, and for project 2 we are getting null. Then again, Neelam is working on 2 projects, P4 and P5. Now in this case, we do not have any multi-valued attributes, and thus this table is in first normal form. But now, again in this case, if let's say only 200 students are working on 2 different projects and 800 students are working on only one single project, then in that case, how many null values are we going to get? 800 null values, which is also not a very good database design. We cannot have so many null values in our relation, in our table, right? So even though this table is in first normal form, this is not a very good database design. Let's look at another way of transforming it into first normal form. Now we are building 2 different tables for 2 different concepts. First one is the student's data, his own personal details, and the second table is about the project details of the student. Now in this case, we are only having the student ID and student name. So student ID will act as the primary key here because it is not repetitive, right? Student name may or may not be repetitive. Then in this case, student ID cannot be the primary key because for student with student ID 1, we have 2 different projects. Then again for student with student ID 3, we have 2 different projects. So student ID is repeating here in this case. So here for this table, student ID will be the foreign key, but the project will become the primary key because the projects are not repeating. But what if 2 different students are working on the same project? Let's say Ram and Neelam. Both are working on project P1. Then in that case, project also will not be the primary key. Then a combination of maybe student ID and project can be the primary key. That means we can have composite key as the primary key, right? This we studied in the normalization concept also. That is in normalization also what we did. We took an example wherein there was a lot of data in a single table and the database design was not very good, right? So we separated the table into 2 different details, 2 different concepts, and then we got a good database design, right? If you haven't watched that video, please do so. It's also very interesting and it is the base actually for the normal forms. So this was the first rule, that is the attributes must have atomic values. Then the relation is in first normal form. The next rule states that if the attribute domain is not consistent, then the relation is not in first normal form, right? Now we've already studied the integrity constraints in a previous video, right? I'll link that video above as well as in the description below. Now out of those integrity constraints, we also had one domain constraints, right? Domain constraint states that if we are declaring a particular column's data type, then that column can only accept those data types. For example, for student ID here, we are declaring that the data type can only be an integer, right? So this column will only accept the integers. We cannot have A4 here. This is an unacceptable value, right? So if we are declaring a domain constraint here, then the domain constraint should be consistent. The attribute domain should be, the domain of that attribute should be consistent. If let's say I'm storing name here, I'm declaring that this can only accept characters, right? Then in that case here, if I write Rakesh 72, then this will be an unacceptable value, right? We can only accept characters in this column. So attribute domain should be consistent. When the attribute domain is consistent, the relation will be in first normal form. Like here, if it is age, we declare the age to be integer, right? So we can have 17, 18, 20, any age here. Phone number also, we are declaring it to be integer. So this will also accept only integer values. If this is the case, then the table will be in first normal form. The third rule states that if there are repetitive names for attributes or columns, then the relation is not in first normal form. Like here, this attribute or this column has the name project, and this attribute also has the name project. So when there are more than one columns or attributes with the same name, then we will say that the table is not in first normal form. So this is not allowed. For a table or a relation to be in first normal form, there should be unique name for every attribute or column, right? Like here, this is student ID name. Then here we can have project or proj1, and then we can have proj2, right? So both of these columns are now having different names, and thus this table will be in first normal form. The next rule states that if the order in which the data is stored is fixed for both rows or columns, then the relation is not in first normal form. That means if you are fixing that 2 should come after 1, 3 should come after 2, it should always be in this sequence, then the table will not be in first normal form. Or if we declare that the project has to be third column only, name has to be second column only, first column will always be student ID, then again the table will not be in first normal form. So the order in which the data is stored is not fixed, then we say that the relation is in first normal form. That means after 1 we can have 3, then we can have 2. We can have any number in any order. The order is not supposed to be fixed, right? Then after the student ID column, we have the project column. Then we have the name column. So we are interchanging the positions of the attributes. So the order of the attributes or the data stored in the rows is not fixed. When it is not fixed, the relation is in first normal form. So there are 4 rules for an attribute to be in first normal form. If there are multi-valued attributes, then it is not in first normal form. It can only accept single-valued attributes for a table to be in first normal form. Attribute domain is not consistent. Then also, it will not be in first normal form. Attribute domain does not change. The integers will only accept integers. Character column will only accept characters. If there are repetitive names for columns or attributes, then again it will not be in first normal form. There should be a unique name for every attribute or column, right? Then the order in which data is stored is fixed. Then it will not be in first normal form. The order in which the data is stored does not matter, right? Then the table will be in first normal form. I hope all of these 4 rules for a table to be in first normal form are clear. If you have any doubts, any queries, you can write in the comment section below. If this video helped you, please don't forget to give it a thumbs up. Subscribe to the channel. Thank you so much for watching.